Section 2.4 Sum of infinity of a geometric sequence. You found that in a geometric sequence, sometimes we can find the sum of infinity. That means sum up equals to infinity terms. Okay? So what is the meaning of infinity? Okay, let's see. By using 2.4a, let us discuss all together. Here, we consider a term y equals to 1 over 2 to the power n. Okay? So when n equals to 1, that means 1 over 2, right? That means 0.5. When n equals 2, that means this one, so 1 over 4, 0.25. How about n equals 3, 1 over 8, right? 0.125. Okay? This one, 1 over 32. Next one, power 10, 1 over 1024. If 20, then up to this one. If 40, then up to this one. And you found that when n getting larger, this one reaches to 0. Sometimes you see right like this. When n getting greater, so when n tends to infinity, then this one tends to 0. Tends to, we use this symbol, okay? Tends to. That means it becomes nearly equals 0, okay? Then, sum to infinity of geometric sequence, what means? That means we pick up, okay, for example, 1 over 2, 1 over 4, 1 over 8, 1 over 16, etc. So the first term now is 1 over 2, right? How about r? R equals 1 over 4 over 1 over 2. And you see that this one is 1 over 2. This is the common ratio. So how about Sn? Here 1 over 2. There are n terms, so this one to the power n, right? You found that, oh, this one what means? That means here, and then first term times the common ratio to the power n minus 1. So this one is the nth term. Okay? Then over 1 minus 1 over 2. 1 over 2 cancel 1 over 2. So at the end, you get this one, 1 minus 1 over 2 to the power n. When n becomes larger and larger, for example, to the power 20, you get this. To the power 40, you get this. How about to the power 100? That means nearly equals 0, but not. Okay? So as a result, we use a figure to help you to understand clearly. Here, negative 1 over 2 to the power n tends to 0 as n tends to infinity. Again, then we use this symbol. Okay? So here, as infinity, we have this symbol. 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot 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 dot. 1 minus, originally is this. But if we now tends to 0, that means this one tends to 0. So at the end equals 1. Okay, let's see. I use this one to help you understand. This one is 1 over 2, right? Plus 1 over 4 plus 1 over 8, right? Plus 1 over 16 plus 1 over 32 plus 1 over 64 goes on. Can you see? Okay, enough, right? And you found that at the end, you get this square. That means as a whole, 1. Okay? So for a general geometric sequence here, AR square, up to the nth term, AR to the n minus 1 power. For S infinity, we get this one, A over 1 minus R. Originally, Sn equals to this one, A times 1 minus R to the power n over 1 minus R. And you see that this one, R to the power n, it tends to 0. Okay? And when we can find the sum of infinity, the only situation is R in between -1 to 1. If out of this range, we cannot find here. If R smaller than -1 or equals -1, or R greater or equals to 1, the sum cannot be found. So remember, sum to infinity, range must in between -1 to 1. Okay? Hope you understand. Later on, we'll have some more examples.